My name is Dave Taylor. I read rocks. They have a story to tell. This is one of the world's most famous fossils. It is a Tyrannosaurus rex. This fossil is mounted in Alberta's Tyrrell Museum. When the T-Rex was found, it did not look like this. Let's see how it came to be a fossil in the first place. Let's suppose this T-Rex lived by a shallow stream. He was dying, as all living things must do. Had it died someplace other than this stream bed, it would never become a fossil. But lucky for us, it died in a perfect place. Let's see how it came to be a fossil in the first place. On safari in Tanzania, I came across 3 similar scenarios. Case 1, wildebeest died in a river crossing. Case 2 was killed by hyenas. Case 3 was accidental death. Which of these 3 cases might, just might, mind you, lead to a wildebeest becoming a fossil? Case 1. Look at the color of the water. It's brown. It's loaded with sediments eroded from the land by runoff from the rains upstream. To become a fossil, the victim must be buried quickly by sediments. If it is not, it may very well be eaten. Our T-Rex, or the wildebeest, is quickly buried, but not before some bones are washed away. In this case, half the lower jaw is gone, and so are some teeth. Layers upon layers of sediment must be laid down. Pressures build, as we've seen. As the layers of sediment cover the skeleton, water carries minerals down to the bone. Gradually, these minerals replace the bone, and they create an exact replica of the original skeleton. This takes thousands, sometimes even millions of years to occur. North America, 80 million years ago. The central portion was covered by a shallow sea. The Rocky Mountains lay to the west, the Appalachian Mountains to the east. As the mountains eroded and new volcanoes erupted, the winds blew the sediments east, slowly filling the inland sea and burying the T-Rex. Now, all that had to happen was for someone to find the T-Rex. This would not be easy. It was now buried several meters below the ground. Nature helped solve the problem. The T-Rex skeleton lies hidden below the ground. The grassland above sometimes gets heavy rainfall. The land erodes. Erosion has exposed the layers of sedimentary rock. It has also revealed part of the T-Rex skull. A paleontologist will discover it, and soon a team of scientists will return to dig out the skull and perhaps the rest of the skeleton. Fossil rocks really tell a story of the Earth's prehistory and the animals that lived there. This is one of the first fossils to show that some dinosaurs had feathers. It is an Archaeopteryx. This prepared fossil shows the skeleton of a small dinosaur called a Hypsilodontid. Dinosaurs were once believed to be big, slow-moving animals. Does this animal look slow-moving to you? Not to me. This mammal skull is not quite fossilized. It is about 1.5 million years old. It has been washed out of the rock and covered by mud in a desert flash flood. It once lived in a tropical forest. Fossils like this help us understand how our climate has changed. This is a fossil fish. It lived in salt water, but the fossil was found over a kilometer above sea level in the middle of a mountain range. This is the skull of a hadrosaur dinosaur about to be studied in a lab. The plaster casing was put on the skull to protect it. Fossils may look hard, but they are very fragile. Here you can see the backbone, protective padding, lower jaw, thousands of teeth, bubble wrap, an eye socket, and toy frog. Toy frog? This is a prepared mount of an Albertosaur, a type of T-Rex, feeding on a horned dinosaur. Mounts like this use life-size casts of the dinosaur bones. They are lighter and easier to work with than the real fossils. The actual fossils are kept for further study. This is a restoration of an Allosaur. Model makers base their work on how living creatures look. No one really knows what color a dinosaur was. It is an artist's best guess. I work at a place called Riverwood. There I see the effects of erosion every day. It is quite a story to tell. Look at these two pictures. What do you notice about them that tells you something about erosion and deposition? Fast-flowing water erodes soil and rock. Slow-flowing water deposits soil and eroded bits of rock. So here you can see areas of deposition, areas of erosion. You can see where the water is flowing fast and where it's flowing slow. The red dot indicates the same spot on the fallen tree. You can clearly see the erosion that has taken place over little more than 1 year. The slope of the land and the curve of the bank determine whether erosion or deposition will occur. Steep flowing rivers have more speed and erode more rock. Flat stretches slow the water down. The outside of the curve is where the faster flowing water is found. The faster the water, the more it erodes. The slower the water, the more it deposits. The amount or volume of water also affects how much erosion takes place. The river in this picture is flooding, and that gives it more power. Look how dirty the water appears. It is actually carrying eroded material. Rivers that flow through narrow valleys have more speed. Here, the Yellowstone River has eroded away the volcanic rock. This rock is very hard and does not erode easily. The river valley is very steep, and the river is very fast. It pushes along boulders and chunks of rock that have been eroded away. When the river reaches wide valleys, it slows down and deposits its load. In this picture, a beaver dam slows the water even more. This photograph illustrates many of the ideas discussed in this ebook. Glaciers, snow cap, melting, erosion, braided stream, wide valley carved by a glacier during the last ice age, gravel and sand being deposited. This is the floodplain of the Churchill River. The bedrock through which the river flows is very hard metamorphic and igneous rocks. The river has deposited material eroded upstream here, where the river widens and slows down. This is the Grand Canyon. The rocks are all sedimentary and were laid down over millions of years. It is over 1.6 kilometers deep. It reminds us that even places where deposition has occurred, they can and will be eroded someday. This is not the Grand Canyon. It is Riverwood. I walk by our eroded cliffs every week. I can see the layers very clearly. The river has done its work well. These layers tell a story. The layers beside the blue line are all made up of layers of shale laid down by the ancient seas that once covered this land. Each layer took a year or so to deposit. There are millions of layers here. The brown lines are mudstone. These are records of major flooding on the nearby land. The muddy water killed the life here, but left us with excellent fossils. The purple lines show you where the debris from above has fallen. These are some of the fossils collected from Riverwood. They are 425 million years old. When you visit, you may learn about these and other interesting rocks in the property. What story do you think they tell? The processes of fossilization also help to preserve eggs, skin, and tracks. Sedimentary rocks help record past lives. They also affect the lives of animals today. This is Algonquin Provincial Park. Compare this picture to the next one. Do you see many differences? This is Riding Mountain National Park. Looks pretty much the same, doesn't it? There are differences. Look carefully. Same climate, same types of trees, same types of grasses, different rocks. Sedimentary, igneous, and metamorphic. The underlying rock is important to the animals and plants living in the area. For example, both parks have moose and black bear in them, but there are some noticeable differences between the moose and the black bear of Riding Mountain National Park and the moose and the bears of Algonquin Provincial Park. Algonquin bull moose grow much larger antlers than do the bull moose from Riding Mountain. But the bull moose of Riding Mountain have bigger bodies. These differences are due to the soil and the rocks. Algonquin's rocks and soils have minerals needed for big antlers. Riding Mountain's soil and rocks provide the nutrients needed to grow big bodies. The same is true for both parks' bears. Riding Mountain is home to some of the biggest black bears in North America, while Algonquin's black bears are about average. Both these bears are 3-year-old males. The inset shows a mature Manitoba black bear. It weighs over 250 kilograms.